Assalamu alaikum dear students. In previous lecture we discussed the one function. Today we are going to discuss this onto function, which is also called as the surjective function. That is onto function. Now consider two functions from set A to set B as set A is ABC, means it is the domain of this function f, and set B is x, y and z. Here A is related, or the image of A under this f is x, B is related with y, and C is related with y. So this means that here we have only two elements x and y, which are the image elements, or the range set of this f is simply x, y, x, y. So this means that this x, y, it is a proper subset of codomain, that is set B, that is x, y set is not equals to B, x, y not equals to B. Similarly, if we consider here function A and B, A is function G from A and B as A, B, C, D. Here we have four elements in set A and three in B, such that A is related with x, that is G of A is x, B is with y, C with z, and D with z. So this means that the image elements here are x, y and z. So when x, y and z is the image elements, so this means that the range set is x, y, z, which is same as B. So in first function, here we have function G in place of f. Here read this as range of G equals to x, y, z, which is set B in the second case. So this means that here we have two different situations. One in which range is not equals to the codomain. Second in which range equals to the codomain. When range equals to codomain, such functions are simply called as the onto functions or surjective functions. So how to define these functions? A function f from A to B, where A is non-empty set, B is non-empty set, is said to be onto or surjective if for each element y of B. So here we need here at least one element from the range in this codomain set. There exists, this is a symbol for there exists an element x belongs to A, means first set, such that f of x equals to y. So this means that each and every element from B should be the image element of at least one element from A. That is, if range of f, or if f is a function from A to B, then this f is called onto function. If range of f equals to B, that is codomain of a function. Such functions are called as onto functions. Like if we consider an example, or if we consider a function f from n to n defined by f of x equals to x, means identity function. Identity function is that function which relates each element to itself. So this means that here this n contains infinitely many, and these infinitely many n's are related to each other, or related to itself. So this means that clearly it is this onto function, because range equals to the n, which is code. So f is onto function. General method how to prove the function is, because it is not always possible to discuss the function like this, that this is onto or this is not onto. There is a general method, and how to prove this function through the general method as. Now this is the procedure for this. If we consider a function f from R to R, means function is defined from set R to R, where R is set of real numbers and R is set of real numbers. This means that here domain is R, codomain is R, defined by f of x equals to x square. Now the general method for this is, let x belongs to R, then its image in R, means codomain, is x square, because x is related to x square. X is in this R. If we consider x from this first R, then it is related with f of x, which is x square, So this means that here from this first R we have negative numbers like -1. F of -1 is -1 square, that is +1. So this means that each and every negative is related to its positive square. Similarly, the positive is related to the positive. So this means that from this second R, means from the codomain, Negative numbers are not the image elements of any element or the elements from this R. So this means that this is not onto, because in second R we are left with elements which are not the images because we have the negative numbers. So this means that range is simply, for this function, range is the set of positive real numbers. So this is not onto function. Now if we consider same function but change its domain, codomain, that is if we consider R from f from R to R positive, means a set of positives with 0 equals to set A defined by f of x equals to x square. That is, here we are restricting this codomain. In first case, codomain is R, complete set R, but in second, codomain is set A, which is actually set of non-negative integer, this real numbers. Non-negative real numbers means positives with 0, that is R positive union 0, defined by f of x equals to x square. Now how to prove this? Suppose f is onto function. We will prove this by the contradiction. Suppose f is onto, then there exists x belongs to R. That is, if this is onto, so this means that if we consider any element from this R positive union 0, that is set A, codomain, if we consider any arbitrary element which is y, if f is onto, this means that this element is actually the image element of some or the some element or the elements of this set first, which is R. So this means that there exists x belongs to first R such that f of x equals to y, which implies that, but f of x is defined as x square equals to y, which implies that x equals to plus minus root y. But here this x here this x is plus minus root y. Here y is always positive because y belongs to R positive union 0. That is why this under root is always defined. When under root is defined, this means that x is the real number, whether positive or negative. So this means that our assumption is true, hence this function is onto. But if we consider the same function f from R to R defined by f of x square, f of x equals to x square, this means that if we assume that this function is onto, so same situation exists, that is x equals to plus minus root y, but here there are two possibilities for this y. One, if y is positive, because codomain is complete R. So if y is positive, this means that x is defined, means x is a real number, which is true because x belongs to first R. Now if we consider for the same second case as y belongs to negative numbers, that's y is negative, suppose minus 1 by 2, minus 3, minus 4, this means that root of minus is not defined in R, which implies that when root of minus is not defined, which implies that there is something wrong in our assumption. This means that in this case, when we consider same function from R to R defined by x square, f of x equals to x square, the function is not onto. But if we restrict its codomain from R to R positive union 0, then it becomes this onto, because here this assumption is true always. Root of x equals to plus minus root y, where y is positive, is always true or is always defined. Hence in this way we can say that this function from f from R to R positive union 0 is onto, but not from R to R. There is another method which is the graphical method to show whether this function is onto or not. Now let me consider here two graphs. Here graph 1 is this and second is this. This is simply called as the horizontal line test. Now suppose we have a graph whose domain is this, because domain is always represented by the x-axis. Suppose domain is this is whole domain. Now assume that it is codomain, starts from this point up to this. This is the codomain, not range, but simply the codomain of like y-axis. Now suppose when we draw the graph of any function, it looks like this, that is, it is parabola in nature. Now here we have, this is the domain, codomain portion. This is the codomain portion. Now draw any arbitrary line, any arbitrarily horizontal line, that is line parallel to x-axis. Now if this any arbitrary line touches at least one point of this graph, of this curve, then we say that the function is onto. Function is onto. Here if we consider any this line through this codomain portion, then it touches at least one point. Here each and every line touches 2 points. So here we have to consider, the minimum condition. Minimum condition is at least 1 point. So if what these lines touches, or any line touches at least 1 point, then we say that the function is onto. But if we consider it is converse, like here we have a domain is this, codomain is this red vertical line, now the graph for this function, or the curve for this is this is a function which is represented by this curve. Now if we consider here L1 L3 line, it touches 1 point. Now if we consider this line, this red line, it touches at 2 points. If we consider L2 and L1 and L2, it does not touch any point on the graph. So this means that there exists at least one line, at least, which does not touch the graph, If this situation exists, then we say that the function is not onto. So this means that from these two graphs, this is the graph for onto function, while this is not onto function. Now the third one is bijective functions. What are bijective functions? A function is said to be this bijective function if it is both 1 and onto from A to B. This is also called as the 1 onto function. So bijective functions are those functions which are 1 and onto from set A to set B. So thank you.